All right, everybody, we're looking ahead at a mechanism that's not on test 2. It's on test 3. And I'll try to point out some features that we're going to compare to the ones you're going to see next week. We don't have a strong acid. You notice that? Yeah. So she reminded me we liked attacking the strong acid because the H was quite positive, right? Like HCl. If I was forced to pick one of these to be more positive, which one would I pick? I'll give you some numbers, 2.5 and 2.8. I'm not making that stuff up. The I is more positive because it's less electronegative, right? So that's why you're going to attack that instead of H. We don't have an H to attack. I think I left my fat pen on. And it's still a little chubby. There we go. And Br minus leaves with a pair of electrons. Now, you would think you're going to make a carbocation because that looks just like the mechanism where we made a carbocation, right? You'd be right. But iodine is very different than hydrogen. It weighs about 126 more grams per mole, right? A lot bigger, and it has 3 sets of what that hydrogen doesn't have. I wanted to do the full Lewis structure for the iodine in Bri. I wanted the full Lewis structure. What would I have to add to what's already on the screen? Lone pairs. Hydrogen doesn't have lone pairs, right? But iodine does. We're going to put one of those lone pairs on the iodine. And of the 2 carbons here, we're reading about this weekend. Which one would be a better cation of these 2 carbons? Tertiary or secondary? Tertiary because it has more. What's the magic word for substitution? It's got the H word. H is in hello. And the next letter is Y. Hyper, yeah. Hyperconjugation. Tertiary cations are more stable cations than secondary. I know it's not a cation. I'm thinking imagination here. That means when iodine says I can help out by making a bond to the cation using my lone pair, which carbon is he really talking to? The one that spends more time with a cation. Say again, tertiary or secondary? Tertiary. So a third arrow. This is different than next Monday's exam. You can't do this with a hydrogen, can you? You can't do that third arrow with a hydrogen. There's no lone pair. And look at this intermediate. Intermediate is quite interesting. Quite interesting. Iodine has 2 bonds and a plus charge. Yeah. And you made Br minus. So we're going to write some notes here. Write some notes. You don't have to copy the notes. Don't bother. Notes. I dot lone pair made a bond to the C that would have been a better C plus. Tertiary has more hyperconjugation then secondary. There you go. That's a U. That's one note. And the other note, Br minus is going to pop this triangle is not very happy. You know that, right? It's got angle strain and torsional strain. Not as bad as if everything was carbon there in the triangle, because iodine is very big, right? It weighs more than 10 times as much as carbon. Yeah. So that triangle is not very, that iodine, like you took a normal triangle, but iodine's so big, you can open it up a little bit because the eye's so big. Not as sharp the angles now, right? They only have to meet the iodine there. So it's not as strained as a normal triangle, but it's still a triangle. It's not happy. You're going to pop it open clearly. Look, the two products, right? Now, Br minus lone pair will make a bond to the C that spends more time with a plus charge. Interesting. It sounds familiar, right? Watch this. That there is called the attack. I'm going to copy it down. There it goes again. I'm going to copy it down here. It's called back side attack. It means it comes in 180 degrees away from the bond you need to break. Means it comes in 180 degrees from the bond being broken. Bond being broken. So can we use that fact and the fact that it's a backside attack to predict which of these four products is the only product we're going to see? I'm ruling out product number 2 and number 4 because the iodine is on the wrong carbon. Bromine ends up on the tertiary carbon because the mechanism says it's going to attack the carbon that spends more time with a plus charge. Don't pick any of the products where the iodine's on that carbon. Now, which one looks like Br came from the other side of the molecule? The first one. This one's wrong because it's a front side attack. Really, you don't have to write this as part of the quiz. I wrote it above the line. I apologize, but it's okay. Generally, words you don't need to copy them. But front side attack has electron repulsion. Think about it. You're coming in from the same side where there's a bond. You're coming in. See, look, you're seeing electrons seeing electrons. Is that a good thing? No, we want to avoid them at all possible, if at all possible. You come in from 180 degrees away, you never saw those other electrons, did you? You came in from the other side. You were never close. There's that. So after your exam, get used to backside attacks on triangles. That's a triangle, right? We'll start off with our first class next Wednesday after the exam. I'll call it Triangle Day. We'll do 4 mechanisms that have triangles. It's just our first one. But don't worry about that for next week, right? Okay. There's activity 4.